Okay, today, mathematicians, we're going to compare fractions, or decimals, by using fractions and representations. Okay, if you remember our big idea, it's that decimals and fractions are different representations of parts of a whole. So today, to help us compare fractions, to compare decimals, we're going to think about using fractions and using part of a whole. So I'm going to show you how I want you to do this. And today we're going to start with this example right here. So we're going to compare the number 2/10 compared to 20 hundredths, okay? And I know some of you already know the answer to this, but I want to show you how we're going to do it. So the first thing you need to always do with decimals is you need to say them. That's one of our standards, is being able to say them. So every time you do a problem I should hear, you say it at least one time. So you know this is tenths and this is hundredths, okay? So we're going to compare this using fractions and parts of a whole. We know that 2/10 is part of a whole. It's not a whole number, correct? So I'm going to model it with a representation. Here are my 2/10, okay? My whole piece is split into 10 little pieces. Here's 2 hundredths. My whole piece is split into 100 little pieces, okay? So this one's split into tenths, this one's split into hundredths. But is my whole the same size? Yes, it is. Because our part of a whole may be different, but the whole is always the same size. So when you have a fraction, let's write this as a fraction. I'll show you what I mean. So if you look at this, if you look at our whole, here's 2/10. Look at it as 2 20/100ths. The whole is the same size, isn't it? The same number, the number of pieces that are shaded may be different, but the whole itself is the same. So let's look at this one. 20 hundredths, I have 20 little squares colored in. Well, it's the same as 2/10. So these are actually equivalent, okay? So if I were to compare this, I would say it's equal. And the way I know that is because I'm going to turn my decimals into fractions that have the same whole, okay? So how can I turn this into a number that has the same whole? Well, I know that right now it's 2/10, correct? But this is 20 100ths. And I want the whole to be the same. So I've got to change this so the whole is the same. Well, if I open this up, what did I say this was? 20 100ths. So I can change this to 20, change this to 100. Is it still the same? Yeah, this same number is still shaded. I have 2 bars shaded. This one's split into tens, this one's split into hundreds, but I have the same amount shaded. So these are actually equivalent fractions. Now, can you compare? Would you rather have 20 out of 100 or 20 out of 100?
20
well,
out of 100.
It's the same, so it's equal. So if you turn your decimal into a fraction, you can visually see which one has more, okay? Your fraction, the part that needs to always be the same is the whole. We want the whole to be out of the same amount, okay? These 2 wholes, if I look at this one compared to this one, they're both out of 100, and I have the same amount shaded. So 2/10 is equivalent to 20 100ths because we talked last week. If I have a decimal like this, 0.2, does this change its value? If I add zeros, does not change its value. So I can add this 0 right here, and it doesn't change the value. It just changes the number of pieces that it's cut up into. So instead of being cut up into 10 pieces, it's cut up into 100. So the whole is the same size, but the decimal is represented just a different way. Okay, so if you look at fractions, that's easier visually to see that these are the same than this is, right? You know that 20 is the same as 20, but you know that 2/10 is the same as 20/10? Maybe not. So that's why we like to make them equivalent fractions, okay? Take, for example, this problem right here. I have 6 hundredths, and I have 600 thousandths. So, if you look here, once again, are all of my wholes the same size? If I stack them together, my whole's the same size?
Yeah.
Yes, but they're split up into different amounts, right? This one's split into 10, this one's split into 100, and this one's split into thousandths, okay? So my whole needs to be the same, but the number shaded may be different. So let's turn these 2 into fractions that are the same size. The whole is the same size. So we know that I going to make these equivalent? Make the whole equivalent? Well, what do I need to do to 100 to make it 1,000?
Add the 0.
Add a 0. So where else am I going to add a 0?
Add the 6.
Up here. Did that change its value?
Mm-mm.
No. 6 100ths is the same as 60 1,000ths. And let me show you how that looks.
Wait, wouldn't that be backwards? 60 hundredths. You can't get 60 thousandths.
Yeah, there's
Right?
a 0 in front of the 6.
Oh.
Because this is in the hundreds place. It's 6 hundredths. If I add a 0, it's now 60 1,000ths. Okay? Let me show you what that would look like. So here is my little tiny 1,000 pieces. Okay? I need to shade in 60 of them. So there's a little box of 10, 20, 30, 40, 50, 60. Okay? That's 60 out of 1,000. Now, let's see what 6 100ths looks like. 1, 2, 3, 4, 5, 6. Are they equal? Yes. Do you see how that works? You can have 6 100ths. If I split my whole into smaller pieces, I'm still going to have the same number of pieces. They're just smaller. Each one of these is a tiny, tiny piece compared to each one of these that's a little bit bigger. Okay? One of these takes 10 of these to make one of those. You guys can't see it, but if you look at these really close, there's 10 little squares. So 60 of these is going to make 6 of these. Because every time you multiply by 10 or divide by 10, you either add a 0 or take away a 0. So I can add a 0 and it doesn't change its value. Okay? So I turn those. They're not equivalent fractions, are they? But the whole is equivalent. It's out of 1,000. Would you rather have 60 thousandths or 600 thousandths? 600 thousandths, right? That's more. They're still really, really, really tiny, but I'd rather have 600 of them than 60. So if I compare this, 6 100ths is actually smaller than 600 thousandths. Okay?
So it would be 6 hundredths is less than.
Is less than 600 thousandths. Now, another strategy that we're going to talk about tomorrow is you can look at the place value. We've already talked about that. Would you rather, if you look here, you have 6 tenths, and this one you have 0 tenths. So you already know that this one is bigger. But the strategy for today is I want you to represent them as fractions. So you've got to make the whole equal. Okay, so we're going to practice that. Go ahead and stop that.